Yeah, I think that's great,
Yep.
actually.
Okay. Great. Hello, everyone. And this really is great. I'm just pretending that none of you are there. So my name's Belinda Maher. I work for the Department of Transport in Melbourne. And I've been working with transport data on and off for about 5 years. And I'm a big fan of R and the tidyverse, and so I had to think of something to talk to you about. And so I've got some we call it performance data, punctuality and cancellation data that's public that I can show you how to manipulate. So just click in the right window so that I can change the slide. So I'm going to talk about these things. So a little bit about me, just so that you know sort of what background I come from and how I've got to where I am. I'm going to talk about just some general examples of open transport data, which are really cool. I've not sort of really gone into, there's a whole lot of other stuff that's more complicated that I haven't gone into, but I'm just mentioning a few interesting things. I'm going to talk a little bit about a big project that I did with Google Maps, predicted travel time data. It's only one slide, but it was, I've got a whole talk about that online on YouTube. So we're going to talk about Melbourne public transport, and so I'll talk a little bit about it so that you know, because some of you might not be familiar with Melbourne public transport. But don't worry, you don't need to know the detail of how public transport works in Melbourne. You just need to know that there's a lot of it. So it's a bit complicated to analyse it. So I'm going to talk about what operational performance is and give you an example of wrangling some public transport performance data. And I got that data in an Excel file, so I thought I would show you how to get it out. And we're going to do some plotting with ggplot2. I have no idea how long this lecture is going to take, so I'm going to try to make it 2 hours. We'll see what happens, and I can put more or less explanation in depending on how long it's taking. And please do feel free to ask questions, because I have been in transport land for so long that I don't sometimes realise when I'm talking about something that normal people don't understand. So I'm happy to explain, and I do apologise if I say something that you don't understand. Please let me know. Yeah, so let's start. So I love data and maps and trains, and I have worked, I started off in transport. I moved to New Zealand for 3 years and I worked for the railways there. I worked on the electrification of the Auckland trains, sort of metro trains, and they were diesel before, so they were pretty shocking and infrequent. And so that was a really exciting project to work on, and you know, quite a lot of work in 3 years. So when I went back to Auckland a couple of years ago, I cried. I saw the trains running. So, yeah, just because it was such a relief to see them finished. So I've done a grad dip in statistics and operations research. And since then, I've worked in for Public Transport Victoria, which is sort of the government body that gets other what we call operators to run the trains or the buses or the trams or the long distance trains or coaches. So, and I think, and then there's even ferries as well, but we're not going to talk about ferry data because there isn't any. So yeah, so I did unfortunately have to work not in transport for a year, but I've since come back and I actually worked at Swinburne Uni, but in operations. I've come back now and I've spent time in strategic transport network planning, which is very big picture, very future planning. And now I'm working in bus and tram planning. So that's just an intro. So what sort of data is out there? Now, this example is just an example that I really, really love. someone who's really passionate about how slow her buses are. And so a lady called Katie Bell in Sydney, she's more of a data engineer than a sort of data analyst, but she wanted to know, is her bus that she takes, the 370, actually the worst one in Sydney? And she downloaded and collected 130 gigabytes of data, of real-time tracking data, to analyze how late each bus was over 1 year. And that's like a massive, massive amount of data. And it's also sort of quite complicated in its format. So you really have to know your stuff to be able to sort of extract what you want out of that data that's sort of made for something else entirely, because it's made for showing GTFS real time is made for showing the on Google Maps where your bus is as it's coming up to the stop that you're waiting at, and how late it is. And we're about to get that in Melbourne, which is very exciting, but we don't have it at the moment. So I can't do a similar project. So I really recommend watching this YouTube video, because I just think it's great. Yeah, it's so much work, but so interesting that she did that. So next, I'm going to talk about my sort of biggest R project and most difficult R project that I've ever done. I finally kind of finished it last year, I think. Yeah. So what it was doing is, so when you're using Google Maps and you want to predict how long it's going to take you to get somewhere by car or by train or tram or bus or whatever, you can put your destination into Google Maps and it will estimate the time for you. So what I did was, instead of doing that manually, I used R to query that API about, I've run it for different areas, but probably about 20,000 times for one map, because I needed to query both walking and driving and public transport and cycling, and for a whole lot of points. So the data is not technically open data, but it can be obtained for free. You can get a free trial and run a certain number of points. So yeah, 20,000. Yeah, it took a few minutes, but it's pretty quick. So, and now the best thing is that I've taught my colleague to run that code, and I don't have to run it anymore. I don't have to remember how to use it. So it's great. So what that looks like is this. So I'll talk you through this, because this is a bit intense. This is just sort of this is actually a leaflet map from R. So this is what I can generate straight out of R just to check the data that I've got. So this one, I don't remember how many points this is, maybe 1,000 points, I think. And so for each of those little dots, and there's a little center dot in the middle, that's the location where I've said to Google Maps, hey, if I want to go to my office, which is the little grey circle in the middle, which says destination, but you can't see very well, how long will it take to drive, and how long will it take by public transport? And then if you look down the bottom in the legend, what I'm actually interested in is, what's the difference between driving and public transport? Because we wanted to show, we were talking in planning about how long does it take people to drive to the airport compared to if they work at the airport, is what we were thinking about. How long does it take them to drive compared to public transport? And if it's going to take them 10 minutes to drive and 40 minutes by public transport, and it's probably not going to be very reliable, they're probably not going to take public transport. So we wanted to be able to get a big picture of what we could do with that sort of data. So we've been using it. This is just my visualization, but I've got someone who's got proper mapping skills, who's sort of joined the points to land parcel data. Anyway, we've done even more amazing stuff with that since. Anyway, I better stop talking about that. So that's one thing you can do for free too. So other data that's available, geospatial and timetable data. Now, I didn't sort of have time to go through all of this, because it's all quite it's a bit complicated. So I have done a previous talk that's kind of very high level about what sort of data is in the general transit feed specification. So this is not the real-time version, this is just the static version. And this is the data that Google uses just to do those planning trips. So it's like timetable data from public transport goes into a special format that Google read, and then that data is public. So the entire timetable is public for every service. So if you're interested in that, you can look at the slides from that talk. There are packages like Tidy Transit, which can help you to manipulate the data because it's complicated. And I've got an example there of looking at route frequency. So if you wanted to, you could analyze the public transport timetables. So public transport in Melbourne, just for a big picture overview, especially if you're not familiar with Melbourne, this is what Melbourne looks like if it only had public transport. So orange, we have some like shorthand for the different modes. So orange is bus, blue is train, green is tram. And purple is the long distance trains, the V-line trains, which go out into the country areas. So this is just an idea of how complicated all of that data is. And that's just the paths. That's nothing about how frequent they are or anything. So that's just an idea of the sort of data that I look at work. So those shape files, they're called, those shapes are publicly available. Don't know how up to date they are, but hopefully they're up to date. And so I've just got some links from a previous talk where if you wanted to put those on a map and practice your leaflet skills, you can, or not necessarily leaflet, but mapping skills. So that's sort of all the data that I have kind of the most involvement with at the moment. Just a few other mentions. There's other things available, like there is some patronage data. Patronage is how many people are on the trains, trams, buses. Data's not very good quality or very recent or in very fine detail, so that's a bit disappointing. There is a lot of data about road congestion and road speeds. So there's the links there for Vic roads and underneath that, road use and performance. I haven't really played with that data very much. And I just left a link in there for COVID-19 restriction time, sort of a timeline, because we're going to talk about the effect of the COVID-19 restrictions in Melbourne, basically, and everybody staying at home, and therefore the trains and trams and buses being on time. So that's all the other data out of the way. So this is what we're going to talk about. So we're going to look at the rail modes. So we've got metro trains, Yarra trams, and V-line trains. So V-line are the country long distance trains. Unfortunately, we can't easily get data for the bus modes. That's not public. So just wanted to sort of explain what we're looking at, but it's not everything. So what is operational performance? So I used to work in the team that calculates these figures, basically. So it's the number of services, trains, trams, and buses that ran according to the timetable. So how many were cancelled, how many ran, how many, and there are a few other bits and pieces in between, and also how were they on time or not. And on time is usually defined as less than 5 minutes late. So yeah. The picture on the right is actually from the Yarra Trams website, and you'll notice that the Yarra Trams performance in so I think that's February when I downloaded that. It's so good that you can't actually see it. It's gone off because the tram performance is usually not very good because of the traffic, because cars being in the way, and trams being overcrowded. So they haven't even adjusted their graph to be able to see how good that performance is by their standards. So and these posters go up at the stations and on trams, and it's usually quite a political thing, but it hasn't been so much of a problem during COVID because things have been running more on time. So the data we're going to look at is punctuality and reliability. So as I've said before, so punctuality is how many services are on time according to the timetable. Reliability is did the tram run at all, or train or bus or whatever. So this definition comes from the PTV website, and so PTV look after all that that data to check, because they're contracting the operators to run the services, and so if the operators aren't running the services very well, we're not getting value for money as taxpayers. So yeah, they need to track it. So further detail under this, you don't sort of really need to know the detail, but you might look at the data and you'll go like, what does this mean? So this is just kind of, how do you compare, you know, punctuality might not just be at the end of the line, it might also be measured along the route, and it kind of differs depending on which mode it is. So tram is measured at what's called timing points, not just the destination. So you'll see that later on. The reliability is how many services cancelled, but sometimes you might have a service which will do part of the trip, but then it will stop. Or it's a tram and there's a car crash on Collins Street and it has to go around a different way. Similar with there is a thing in Metro Train where a train will skip the city loop, or there's another little loop out in the west as well. So that actually gets factored into the calculation. So that's just what that means. If you're not a massive nerd, it probably doesn't matter. So I mean nerd in a good way. So what data can we get publicly? Because I have access to lots of data at work, but I can't give it to you. So what I can give to you is the monthly performance, and this is what it looks like on their website. And you can get daily performance, but only the sort of performance, the two performance measures, and not by route. You used to be able to get more detail before they changed how they serve this data. So you can get more detailed data from the, well, not more detailed. You can get the data from the Power BI app, because you can only see on the website when you know, the latest kind of data. You can't sort of download months worth like you used to be able to. So this is a Power BI app that my old boss wrote. And the link is where it says monthly performance page, and you can go to it and it looks a bit like this, and you've got different tabs for train, tram and V-line. And you can actually go in and you can fiddle with, it's not very obvious, but you can actually see data that's further back if you change the date fields. And yes, so that's, but unfortunately they've got downloads blocked. So I have acquired the data for you, which is the same as the data that you could look up and type out, but you don't have to type it out. So what sort of meaning can we get from this data? So I've got a couple of examples, and these are sort of, one's an ex-colleague and one's a current colleague, and they're very passionate about data and about public transport. So Chris Loader and Peter Parker. So I've linked to their blogs. So Chris has been looking at pedestrian volumes in the CBD, and I know Di's already mentioned that data, which is really interesting. I decided it was too hard to look at that data, so but it would be a very interesting exercise to do that. And so Chris has done a bit of that. I don't necessarily always agree with Chris and Peter on what they're suggesting, but it's interesting to read it and read it with take it with a grain of salt. Yeah, so you'll see one instance of that on the next slide. But so this, when I say this data could be used to give a baseline level of people in the city during COVID restrictions, that's kind of what Chris has looked at, but you could potentially look at that data compared to the performance data that I've given you. So this is from Peter Parker's blog. So he's done a bit of a rant about train performance, and this kind of inspired this talk. So it's interesting to see how he looks at the data. I don't actually agree with the regression line that he's drawn there. Unfortunately, I didn't have the data downloaded back that far, or I would have shown you that regression line looks wrong. But anyway, so it's quite an interesting article to think about what we're showing with this data. So I wanted to ask what sort of variables you think might affect this data. So why is your train late? Why is your bus late? Why is your bus just not there? Could you put some ideas in the chat? I want to hear good reasons that I haven't already come up with.
Belinda, yeah, according to the question, is according to the perception of the user or according to the performance by itself?
That's a good question. I'm actually asking about according to the data, but you make a good point that how people will say, oh, my train is always late, and then they'll see the performance data for their line and it's quite good. So you might think that your line is always bad, but actually it's just your train. So what I'm asking is just anything that would stop a tram, train or bus from running. So for example, a taxi crashes into a car on Collins Street and the trams can't overtake each other. So then the tram behind will probably be quite late. Yes, lots of examples. So no customers on a flexible route. Oh, I didn't even mention flexible route. Karan, I assume that's I assume you're talking about like telebus or well, I've never taken telebus. Wow, that's very advanced. I don't know how I don't think they're not in this data anyway. Okay, so weather, yes, and there's often flooding on the trains, which, and then they can't run, and police operation, yes, that happens a lot. Accidents, signalling faults, yes. Holiday traffic, yeah, actually there's a bus in down on the peninsula that runs so late because every summer there's so many cars down there. Completely glitches, yes, there was also a time when I think they had to evacuate the control center and all of the trains had to stop because it's not safe to run trains when the control center isn't monitoring them. Yeah, so what else have we got? Yes, maintenance, yes. Less tracks to accumulate so many trains in a particular time frame. Yes, we are getting up against the limit of how many services you can fit on the tracks. Yep, construction, tailgating between cars and trams. Yes, especially if they run into each other. Timetable discrepancies, if you mean sort of like sometimes the timetable isn't very good, well, not very good, the timetable doesn't reflect what the traffic is like, and so like Chapel Street seems to still be slow even in 2020, so maybe the traffic isn't well, we'll get to that later, the Chapel Street situation, but yes, definitely protests quite recently, and yeah, all the time, because I used to see these reports every day. Yes, crowding, yes, emergencies, yes, all excellent. Yep, all excellent suggestions. And upgrades of stations, yes, usually they will have bus bus substitution. What they actually do is those, if there is some works, I think that those numbers are reported in this data, but they're not, the operators aren't fined for it, because it's also all about money. Because there's actually all these calculations that are done. They're not public, but they're done about, well, Metro, you had these trains which were late, and you had good excuses for these ones, so we'll let you off because there was a flood or whatever, but the other ones we're going to fine you for. So yeah. Okay, great. And so yes, there's the slide that I had fun putting together, just thinking of all of the things that I could think of. So some things that might not have been mentioned is like, if you've got, the Glen Waverley line is not working, and so people are taking the Belgrave line instead, and so it's all crowded on the Belgrave line, and so then the trains are late. So that's sort of what I mean by that. All sorts of things. I would see crazy things in the reports every day. Yes, rats eating signalling cables, that has happened. And a bat being, I was just checking whether you were reading, a bat being electrocuted by signalling equipment is actually correct. Well, although actually I think I've read about it since, and it's a bit more like the bat was electrocuted and that shorted out the signalling equipment, and they didn't have backups. So it took days to fix it. Like my train line was out for days, like they had to go at a really slow speed. Anyway, so things that actually improve performance. Weekends, public holidays, school holidays, January because everybody's on holiday and not going to work, or and there's roster days off where construction companies have every 4 weeks, like everybody has a day off, so there's less traffic, and so then the trams and buses are a bit faster. Yeah, so COVID-19 restrictions, obviously, and working from home. Day before Cup Day also, because everybody takes it off, so you can't. It's not a normal Monday in the reports. So my point, the other point I wanted to make on this slide is that there's quite a seasonality in how much crowding and traffic there is, but you can't really see it in the data that I give you because it's only at month level, so which is a shame. But basically, the crowding that you see, and you can see it in the public traffic figures, the crowding that you see on the roads affects whether the trams and trains and buses are on time.
Excuse me?
Yep.
Yeah, how does hot weather affect the public transport?
That's a good question. So particularly for trains and to a lesser extent trams, so when it's hot, the rails expand, and the rails can actually buckle if they expand too much. So they have what's called a temporary speed restriction, where the drivers are not allowed to go above a certain speed because it's too dangerous, because the track's a bit dodgy, because it's all sort of stretched out by the heat. Yeah, so that's why hot weather is an issue for, more so for V-line, and to some extent, I think you would sometimes have a restriction when but we're talking about like a 40, 45 degree day, where that would be enough to affect how fast the drivers are allowed to go. So millipedes, that was one of the things on the list. So you wouldn't believe it, but so I was going to say, similar to electric wires, signaling cables are the cables that run beside the track. You'll see them in a little sort of trenchy thing, and they tell so they've got these little traffic lights for the trains, and they run those. So if the traffic lights are down, trains don't run because it's too dangerous. So.
May I interrupt in, Belinda?
Sorry,
interrupt in. Just that I meant for the hot weather thing.
Yep.
Similar to electric wires is something like wires are also loosened up and tightened up in winters and up. So it's something the similar thing.
Right. Yes.
That happens with the tracks. Yeah.
Okay. Yep. It's probably even worse for tracks, because they're so big and heavy. So you've sort of got more to expand, and also this sort of they're tied down to the sleepers. You know, that they sort of need to, like, if you have tracks that are too far apart or too close together, the train will fall off. You know, so you know, that because the tracks are sort of being stuck like this, if they're sort of trying to push to make themselves longer, it can mean that they wiggle. Yeah. So I'll quickly talk about the millipedes. My colleague told me about this 5 years ago, and I'm like, what? Millipedes slowing trains down? So what happens is all the millipedes, they crawl on the track, and then this is generally the V-line trains, the long distance trains. If they get squished by the train wheels, there's not actually a lot of space that the train is sitting on. Like, there's a very small amount of actual track to wheel contact on a train, and so if that little bit that's touching has got a squishy millipede on it, you might not be able to stop, and so the trains have to run very slowly because they can't grip the track because it's dangerous. So, and I've got an article about the bat, which is no longer with us and caused several days of delay to my train line. So that was just something interesting. You just wouldn't believe what you see. And another thing that you see a lot is suicides. And I mean, it's not a nice thing to talk about, but I had to stop reading the reports because it was too depressing. Like, yeah. So yeah, anyway, something nicer, the Tidyverse. So let's have a look at some of the data from that Power BI app. And like I said, it's how I got the data, and I could have cleaned it for you and made it nice, but you should see data how it really is when people give it to you, people who are not tidy in the R sense. So we're going to use, hoping that you're a little bit familiar with some of these packages, but I've tried to go through it all in detail. So we can download the file. I've put it up there on the website. So I've given you even automatically, you can automatically download it with this command. So I've sort of talked about, you can also use the here package if you want to, like, if you want to save it and then you want to see, oh, which files are in the directory that I'm in at the moment. So yeah, I've kind of used this because I needed to be able to compile the lecture from the GitHub repository that we're using. So you can just ignore ignore the folders in there and take them out if you wanted to run this code. But I give it to you all in the tutorial anyway, and I've tidied it up a bit. So firstly, so we get the file name down here, and we put it into, and we've loaded the packages that we need. We put it into Excel sheets. So Excel sheet says, okay, what are the names of the sheets in this file? And they are Metro, Yarra, and V-Line, because they're the modes that we're going to look at. So you can do a fancy thing and read them all in at once using the Per library, which even I still struggle how to remember how to use it. It does the same thing as the code beneath that, but I just wanted to show you a really neat way of doing it. And I checked, and it does do exactly the same thing. So then there's just a little step where I then, so this is like a list of the 3 different sheets that have been read into a list. So you just want to put the names of those sheets onto the, I'm trying to think whether I showed this in the code, possibly not. You put the names of the sheets onto the little items within the list, so that it knows, so that when you manipulate the data later, it knows whether it was a Metro, it was from the Metro tab or the Yarra tab or the V-Line tab. So then what you can do is use dplyr, and you can pull all of those 3 sheets that are sitting in a list into the performance data frame. And this bit of code here, ID equals mode, what it does is it, see, I've asked that in the tutorial, so maybe I won't tell you what it does. No, I will. It takes the, it puts into a mode variable the name of that sheet, so that you then have that in the, so then you see the mode down here in the tibble, you know that that's a Metro Trains line. This select statement here is just, there's a whole lot of variables in there, and I just turf some of them out. So so then, yeah, firstly, you know, I thought this was going to be a really easy lecture to write, but it took me so long to sort out the data that I thought, well, I'm going to show you what I had to do to get the data in a nice format. So you can, if you want to, you can filter the data, because if you're getting, I've given you from 2010, and that's probably a bit too much data to graph, so you can filter it if you want to, but here you can group by. And so what that means is you, it's like doing something for a pivot in Excel. So you can say, take all the ones that have the same service year and mode, and then go to the next line where I've got a summarize. So for each of those little groups, add together all of the number of services scheduled and call it number of services scheduled. So that's the number of services scheduled equals the sum of that for that group. Hopefully you've seen Magritte before. I use it a lot. I know it's a bit confusing at first, but it just makes it a lot easier to follow code. So there, and then we always ungroup, because otherwise it sort of stays grouped up, and it, yeah, gets confusing and error message. So if we do a head on that summarized data, you can see that it's just taken anything the same year and the same mode, it's just added them all up. So that was just a first simple example to show summarizing. So is that, any questions on that?
I have a quick question in here. For the ungroup thing, it is not something which is stored up in a variable. So why was ungroup needed?
I think if you don't ungroup, Di might be able to correct me. I think if you don't ungroup, you get error messages, and you get like you've still got a grouping on that. They may have changed this behavior since I was last ungrouping, but it's just to do with like I deal with it a different way, I think, in the tute, but it's just because otherwise you've got a grouped data frame instead of just a normal data frame. You don't want the groups still sitting there when you're using it later.
Yeah, I mean, I think that's a good explanation. And I have to say, Belinda, I think it's good for you to do that. I feel like I'm a little embarrassed. I feel like I don't want to do that because people think I'm just hacking stuff, but it's not actually. It trips you up in sometimes. Sometimes everything's fine, but if you don't do that ungroup, it'll catch you. It'll come back to bite you when you're trying to do something else. It's just because when you group by, it adds an extra sort of state to your data to say you need to treat these ones separately from these ones.
That's right.
And it's good. It is actually good to have that ungroup on there. And so I'm going to use it a lot more frequently.
Well, because I was reminded of, there's a Alison Horst cartoon which says like, always invite ungroup to the party. And it's really cute. And so that's why we ungroup, because what you should do is you should go and try that code and see if it might give you a warning saying, oh, this is a grouped data frame. So
summarize function automatically ungroups, right?
Does it?
Yeah.
Oh,
for one variable.
I think it depends on how many levels of grouping you're doing. But anyway.
Yeah, not always. I don't think it always ungroups. It's yes, I think you'll find you're mostly probably okay, but I still occasionally run into problems when it doesn't happen.
Yeah. Okay, so that was summarizing up to just everything that happened in a year, and that's just for one variable. So what sort of variables have we got? So we've sort of got the ID variables, and then you've got like the number of services that were, now I mentioned short before, is when it didn't do the full trip and cancelled, bypassed, all those sorts of things. And I've left one of the percentage measures in just because we're going to do a graph of it later. But generally, so this data is kind of at a level where yeah, Steph agrees with me that you should ungroup. We're going to, this data is currently at a level where if you open up the data, you'll see that there is sort of these percent on time and reliability percentage measures in there, but they're at every single line, and there are, so what about, so there are 26, if you look down the bottom of this slide, there are 26 different tram lines, 11 V-line routes and 16 Metro Trains routes. I think that doesn't include the showgrounds because that doesn't count as one of these measured routes. But anyway, so we've got a lot of different, what's called a parent route, which is the just the, you know, the tram line or the train line or the tram line or the train line. So we've got these things that we've calculated that have been calculated for us, but they're at too detailed a level. So if we plot the, so this is filtering on tram. So there are 26 lines here, and I've just colored them by a reporting group, which you'll see in the tute. So that's kind of like a higher level of the data. You know, it'll have a few different routes together. You know, all the trams that go down Flinders Street are blue, and all the trams that go down Elizabeth Street are green. So I just did that because if you have 26 different colors there, you can't see the difference. So this data, we're looking at line by line, but for the graphs that we want to look at, we just need a bit of a bigger picture. So what we'll do is we'll summarize this data, but we'll need to recalculate these measures because they've got complicated. You know, you can't just say, you know, March performance, you know, plus April performance plus May performance. You can't just kind of, because there's different numbers of services in each month, so you can't just treat them as equal. You sort of have to summarize them up. So here is where I've grouped by, I've included the ID fields. So I've got the date, the year, and the month. I mean, they're sort of a bit redundant, but I've done it just to make it easier for what I do later, and the mode I've grouped by. So what that says is, okay, stick them together if they're the same service date and mode, and then I want you to summarize. So it's like the one we did before, but anything that starts with NUM, and the name for each of those is going to be what the column name was. So that's kind of like a way of doing a summary without having to, you know, rename each or type out each column name individually. So if you run that code, so we've got our initial, like, just raw performance data. So I've called it perf month. And so that just summarizes everything within the same mode together in one month, and you can see down the bottom that it does all the other variables as well. I've deliberately excluded the percentage one because I want to recalculate that one at the new summary level. It's a bit hard to sort of get your head around this, like, summarizing and unsummarizing until you kind of see the data and play with the data, I think. But hopefully the graphs will make it a bit easier. So how do we recalculate these measures? This is from and this hasn't worked in the, because the image goes off the bottom, it hasn't worked in the PDF slide, but in that dashboard on the PTV website, I have, I've just taken a screenshot of all the detail that's in there, all of the different ways you calculate things. And this used to be my job, so I'm familiar with all of this stuff, but you don't need to care about it. You just need to use this code to do it for you. So this is all the complicated stuff that goes on behind the scenes in the PTV database to calculate those measures. So from multiple variables. So next step. So we've got any questions so far on that? Well, not on that because that's complicated. But do you kind of see how, like, initially, I probably should have put some more graphs. Sorry? I probably should have put some more graphs in, but oh, you're cutting out, Di.
There's a good question in the chat.
Oh, right.
There's a good comment in the chat or questions.
Okay.
And just the questions about group by and ungroup in the chat would be good to talk about.
Yep. Oh, as soon as I accidentally close the chat, I get questions. And why can't I see it? Chat. There we go. Right, it hides itself in the screen share. Okay, right. We would not get the correct values for sums for daily amounts if we did not group each day together first. Yeah, we actually don't have daily amounts. It's more the months. It's like, because you've got a so you can we see that month? Yeah, see, just on this screen, you've got Metro month 1 and month 2. There's quite a different number of services in each. So each time, I mean, there's other ways you could calculate this. I've approached it in this direction. You could actually do it by, you know, just changing the denominator, but it's sort of, yeah, I think it makes more sense to approach it this way. Yes, when we are plotting, we don't want to have group data if that's going to be an issue. But was there a question? Oh, okay. Why don't we choose not to group? That's a good question, Janice. So why do we, if we're going to have to ungroup the data, why are we grouping it? Because R needs to know what I want to summarize the data by. When it's doing the summary. So either here, or it might be easier to see in this one. So here I've grouped by year and mode. And then I do the same thing. Then I do a similar sort of thing, but I'm doing it at more, doing it with more detail. So this time I've got the months, I've got for each 2010 value for each mode, I've got one value for each month, whereas before I only had one value for the year. Yeah. And some, so R doesn't know what level I want to add it together at, unless I tell it in the group by. So that's why we need to do the group by.
Sorry.
Yeah.
By saying that, so we have to group by. We have to use group by before we summarize every time, right?
Yes. I think so. I don't. It's a bit hard for me because the syntax has changed so many times since I learned it. But I'm pretty sure. So I had to learn this new across function. But yes, because if you just tell it to summarize, it'll be like, well, if you haven't grouped it, I guess it would probably just give you one number for everything in the column.
Right.
I think so.
Right.
Okay.
Yeah.
What is being summarized, mean or standard deviation? We are actually looking at, at this point, we're just adding up. We've got all of these. So if you look down the bottom, there are all of these variables. How many services were cancelled? How many were short? How many were bypassed? We're just adding to, we're just re-aggregating those at the right level. so that we can then do the calculations. So that we can do these calculations, and then it comes out with, so when we run this calculation here on this slide, we end up with, and then I sort of select, I get rid of the other variables because I don't care about them once I've done the summary. So it gives me this reliability and punctuality measure, because that's all I want to graph in this case. Does that explain that okay? So like we're not doing like a mean or a standard deviation in this case, because we're not sort of looking at the mean. We've already got sort of really summarized data. Like we're not looking at the mean lateness or, you know, for each service, where we're just looking at like, it's more of all the services, because this is actually in theory, this is a population sample. Like it is the whole population, apart from where they've, you know, the tracking system wasn't working or whatever. We have we know about every service, whether it was late or not. So we're not actually inferring about the population from the sample. We have, I can't remember what the statistical term is for that, but we have everything. Yeah. So we start off, as Mohammed says, yes, it's a sum of, yeah, you start off with and I call it, what do I call it? I call it perf month, where I've got just it's exactly the same as doing a pivot in Excel, where you just want to summarize the data, but then I do the calculations that tell me, okay, according to PTV's rules, this is what the reliability measure is based on the inputs that I got from that summary. Okay, yeah, I'm sorry, it is, Karan, it is a little bit confusing, because it's just data that's really specific to this industry, and I've been looking at it for years, so I just know, like, it makes sense to me, but only because I've spent a lot of time looking at it. But I think if you play with the data and look at the data, I think that will help you a little bit to get your head around what we're doing. And I'm sorry if I've made the tute really hard, but I have the solutions will go up. Okay. All right, so we're at almost at 6 o'clock now. Yeah, I think, like I said, I think when you run this code and you see at each point, you see what, then you know, do a view and do a head, you know, have a look at, oh, okay, that's how the data is arranged at this point, and hopefully you'll be able to follow through. Yeah, cool. And you'll get lots of practice in the tute too. But I have given you, over the last couple of days, I sort of got all the code so you can just run it basically, and then you're just changing some variables on code that I've already given you to summarize it a different way. Okay, well, we're getting to almost to 6 o'clock, so there's probably a few other questions that I will answer in a moment if I've missed any in the chat, but I did ask Di, and she said we should have a little break. So I'm going to get some more water, and I will come back in 5 minutes. I will set a timer, and yeah, feel free to you know, get up and walk around and ask more questions in the chat if you want to, or if you want to ask verbally when I get back, that's cool too. All right, so have a break for a moment, and it will probably take me a moment to turn my camera off. There we go. Okay, see you in 5 minutes. Okay, well, just while we're waiting for people to get back, I'll answer Janie's question. In my real workplace, yes, I use R. I used to use SQL to usually within R to query the databases that hold this data when I was in that team, but I don't have access to them anymore, so I can't use SQL. We have Power BI is widely used, and so we need to use, I mean, in theory, I might have to learn DAX to query some of the bus performance data that's in our Azure data lake, but mostly I just use R. I do have to use Excel sometimes for spreadsheets that consultants have worked on, but thankfully I haven't had to do that for a few years, for a couple of years now. Everybody's sick of me saying, oh, why don't we do this in R? So hopefully that answers your question. So, all right, so where were we? Oh, and also I have used Tableau, which is quite cool. And there's, I'll add them to, oh, I think they might be linked to in the lecture notes for the talk I do about GTFS data. You can do some cool mapping stuff with Tableau, but you know, nothing that you couldn't do better in R really. So yeah. Okay, so where were we? We were talking about how we've summarize this data up into adding all the lines together, so sort of like removing that line variable and summarizing back into just the sum of those values for the mode, and then what we do, then we ran the calculations to give the sort of dependent variable, the sort of the performance measure for reliability and punctuality. And you'll notice from the calculations that they don't actually mean exactly the same thing for each mode, because you have different sort of inputs and different calculations depending on the mode. So so here what I've done is used a select so that I get rid of all of those number of services things, because I just want to look at the summary data, and I just want to look at reliability and punctuality. So this data is not tidy now, because the way I've done that calculation, I don't know if there's a way of doing it so that it just spits out in a tidy format to start off with. So what tidy data is about is having, and I'm sure that Di could explain this a lot better, having your all of your sort of ID variables in columns, and then having your value, just sort of one value for each of the sort of ID variable combinations. So here, if we search just for, okay, give me metro trains, or if we filtered down to a line of metro trains, we have two different columns holding the values that we want, reliability and punctuality. But what we want to do is have them like this. If you look down at the bottom of this example, we want to put them in a value column, so that, and really for the graphs that I've done, you didn't really need to do this. You need to do it for one of them, but I wanted to show you how to do it so that you can, and this is kind of a pretty simple example, because you only need to tidy up, you know, two columns into one. So you can do this to tidy data for other more complicated data sets. So what I've done here is, after so selecting just for the columns that basically the ID variables and the two measures that I want to make tidy. So I've used pivot longer, and I had to look this up because I've been using R for so long that I was still using, I think I was using melt and cast 5 years ago, and I didn't want to change from melt and cast because I was used to them. But So Di will probably be laughing about that, but you guys might not have come across them. So the syntax for these has changed a lot over the years, and I went to a really excellent talk by Hadley Wickham, which I recommend you all watch, because yeah, it was very well, I thought it was inspirational. He talked about how we can blame him if we don't remember the syntax because he hasn't designed it well, if we can't remember it. So that was great, and yeah, I personally thanked him for that. I was so impressed. But anyway, I just like to blame Hadley, not me, for not remembering the syntax. But anyway, so what we're doing here is we're using pivot longer. And so we take these two columns at the end, the reliability and the punctuality, and we want to squish them together so that we've just got a value column and then a measure column which says, well, this is the reliability or the punctuality for that line. And I also go through and I round the data so that it's just one decimal place, because it's only reported at one decimal place. It's sort of not, you know, you don't need to know more than one decimal place for this kind of data. I mean, I guess if you're actually statistically analysing it, you would, but yeah. So this slide shows how to use that pivot longer to change the data from this format where we've done those calculations by line, and we have both a reliability and a punctuality, and we just want so it's not a smaller data set, because you have to repeat the data because you've got two values for each combination of ID variables, but we will see later why it's important to do this. So we'll take a deep breath, because we're going to get into ggplot, and it's I don't know if you've used it much before. Oh, good. Di loves melt and cast as well. That's good. I thought, oh, I can't be teaching syntax which is giving me like deprecation errors. So, yes, and yes, I don't know whether I almost didn't use gather and spread, because they kind of were only around like at a time when I wasn't doing much of this kind of stuff in R. But yeah, anyway, so any other questions so far? We're all good to go on to ggplot? Yep. Okay, so what we're going to do is do some simple-ish graphs, so the first two are simple, of the data to see what we can see is going on. So we're going to take the tidy data that we tidied, and I just show dplyr colon filter, because I have been stung too many times by filter clashes, because it's in dplyr and it's in another package, and you get this weird error message and you're like, but this code worked before, I don't understand what's happening. And you know, it takes you ages to realize, oh, it's just because the wrong filter was being, the wrong what's the word, the wrong function called filter was being used. So you can do that other ways as well. You can use, there's a package called conflicted, or you can be careful about the way you, the order in which you load your packages. Anyway, so that's why you see dplyr filter everywhere. Okay, in my code. Okay, so we're going to take perf tidy. We're going to filter only for the Metro Trains data, because remember, we've got 3 different modes in there for every single one, and we just want to look at one at a time in this case for something simple. We're going to filter out anything less than, less than or equal to 2016, just because you just get too many lines in one go otherwise. And we're only going to look at the reliability measure. So making the data tidy makes this a bit more complicated, because then we've got to filter by reliability instead of just using the reliability value, but we'll see why I did that. So for our ggplot call, we can put the data the call for the data in here. And there's many other ways of doing it too. So we get AES, so that's the aesthetics of the plot. So what you want to do is tell ggplot, okay, this is my X value, this is my Y value, and then down further, we've got the color equals, and that's, we want to show a different color for the different values of that variable. In this case, we're using color service. Yeah, excuse me. And the reason, I'll just mention this while I remember, the reason, yeah, I'm going to explain the month thing, that's complicated. Don't worry about that. So the reason I've put as character there in front of the color is because when the data loaded in, and there's other ways of loading the data so that you force it to be the right type that you want it to be. But I was trying to do it quickly, so I haven't changed. You could change service year, the whole what's the word? The whole column to just be in a character format. But I'm just quickly putting this as character there to show you, if you don't do that, you're going to get a, it's going to treat it as a variable that sort of a numeric variable that varies, and so it'll just give you a ranging blue to dark blue, and it's not very easy to see. So that's just a quick way of fixing it so that it does a separate color, because it says, oh, 2016 is no it's not numerically on the same scale as 2021, so I'm not going to put it all in one sort of color scale. So it's just a way to make the colors go easily. So I need to explain, yeah, so aesthetic. So X equals, now, okay, let's start at the middle. So we'll start with service month. Now, if you, I probably should have left these examples in. If you have service month and you just put it in there without any of this, if you just put X equals service month without that and without the levels, you just get, it's reading them as numbers, and I think it's even reading them as text numbers. So because they're just in there as 1, 2, 3, 4, it reads them a test. So you get like you get 1, and then you get 10, and then you get 2, and or you probably get 11 and 12 anyway. So it to get the, what that does is it puts so it takes, so month.abb, what that does is gets a month abbreviation. So it's like just a little list of the month abbreviations, and you're saying, I want the one for, in this month 1 is, if I put month 1 in there, I get January. And what the factor does is it creates, so instead of a list of character kind of Jan, Feb, March, which it might sort by alphabetically, we want to sort it by the order that months happen in. So this is just a way of, and I know it looks ugly, but it's a way of quickly fixing the data so it comes out beautifully like that. So that's what the month levels does. Yeah, so month.abb is just goes in and gets the abbreviation out of a list. There's probably a similar one for the long one, but we wouldn't have space for it. So X is our months, and Y is our value from our tidy data. We're coloring by year, and we group by year. So you need what the group does in ggplot is that it will it lets ggplot know what the sort of ID variables are, like what it needs to group together to plot. You can see you'll when you're trying in the tute, you'll find what happens when you don't do it correctly. So Ziao, you've raised your hand.
Yeah. I've got a small question regarding here.
Sure.
So can I understand here the code after the x equal to the factor? So you are forcing the numerical data of the months because before it's like a year, month, day, right? It's a numerical, and then you force it become a text, right? Because you are using
close, but not quite. If I had selected, so there's service date in there. So if you see down the bottom there, there's a, and so that's been read in as a date time, even though it's only a date. So if I was using service date, I could pull the month out of there. This is why I said that these are redundant variables, because we have the date. And I could use functions to get the month out of that value, but I've already got the month here. So I'm just going to use that just to make it easier, so that I don't have to teach you about date time functions. So what it actually does is, so see how its service month is just one there. So when we go here, so it's basically saying, like, so it's kind of like if you just had a little list saying January, February, March, and you said go to 3, it's going to return March. So that's what this month.abb does. And so, but the stuff around that, it does it as a factor, just so that it ggplot will be able to display it correctly. Because if you just have month.abb, like, you'll be able to see, yes, that says MAR, but it's it needs to be in the right format for ggplot to cope with it. Does that make sense?
So the factor actually is forcing the ggplot to make it orderly.
Yeah, so basically what it does is, when you have factors in R, they're used for, like, experimental sort of, if you think about data about experiments, you will have a factor. So you'll have, like, you'll have male subjects and female subjects, and you'll have ones that are, I don't know, different races, different eye colors. And so that usually you want to deal, most of the time you want to deal with that data as a factor, because then you know what different levels there are in they're called levels, what different levels there are in the data. And in this case, when you tell it the levels, that levels equals, that's doing a put them in the order that they are in yes, Mohammed, month.abb is inbuilt. Yes, it's not one that I've, sorry, I didn't make that clear. Yes, that's built in. That's yeah. So I'd never used it until I made these graphs. So does that help to explain?
Yeah, sure.
I think what you should do is go run this code, take this code and run. So run it just as service month, see what happens. Run it month.abb and service month, see what happens. Yeah. And then put the rest on, and then you'll see, oh, okay, that's why she's done that.
Yeah, so basically, in my understanding, correct me if I'm wrong. So what you're saying, the factor is kind of you are modifying the variable you are interested in, which is the service months, and modify it through 2 modifications. First, change the numerical to the text abbreviation. Second, order them by levels.
Yes, that's right. Yep. And I could have done that. I could have done that to the data, to the underlying data, and then I would just be able to feed service month to just by itself. So I've only done it there because I was sort of just doing my cleaning as I went. So yeah, I probably could have I could have made it clearer by changing that data before we got to this point.
Yeah. Okay. Thank you.
But it's an important lesson to learn, because I didn't know it until I don't know when it was, a couple of weeks ago when I was writing this. I'm like, oh, why is this doing that? Yeah. So.
Okay. Cool. Yeah. Thank you.
Cool. No worries. Okay. So. Mohammed says most of the visualizations and inferences depend on the formula. Yep. And yes. Oh, thank you. Yes, it did take I got that function wrong. Yeah, so please, if you do find any of that data that doesn't match what's in the public reporting, I've got the function wrong, so please tell me. So yes, it's complicated. And I had done it before a few years ago when I worked in that team. But okay, so where were we? So we've explained what the month.abb does and what factors are, and you'll probably come across them in future as well. You'll need to know them. So we've coloured by the service year, and I mentioned the as character. So the group, like I said, you will know if you get the groups wrong, because you'll get a crazy graph and you'll be like, oh, okay, you need to tell R what to do, how to group, how to draw the lines, basically. So then there's plus labs title. So you can do, you can give the graph a title, and you can give it, I've just overwritten the X and Y axes, because if you don't say X equals month, you're going to get all of that as your little title down there, which looks ugly, and you don't really want to see for the in the legend, you don't want to see as character service year at the top of the legend. So that's why I've changed so that as character service year, that would come up down here if I hadn't overwritten it with this color equals year. Okay, so more important than the labels is geom line, which actually tells that, yeah, I want to draw a line graph. So there are other ones, like there's geom path, or there's you can make bar plots, and I haven't actually used ggplot that much, and when I have used it, it's always been for line graphs. So, and like I say in the tube, don't be afraid, like if you run the code and it breaks and it doesn't make sense, just try something else, change a variable, see if it helps. Now the theme down the bottom, that just puts that legend down the bottom, otherwise it automatically comes up down the side, and that just makes it harder to fit into this slide, because I was struggling to fit it in as it is. Right, that was quite a thing. So what is the group argument? Okay, so hopefully I've just explained group. It's kind of like you have to tell R how many different kind of types of lines it needs to draw. Yeah, you'll see some more examples of me using group, and hopefully that will help. There's only a few slides left, but there's sort of complicated, so hopefully that will help a little bit in the understanding. Color arg does group. What the color does is, if I didn't have the color equals year, all of the lines would be the same color. So that's sorry, color equals as character service year. That's the label being changed there. Up here, yeah, you would just have all the same color if you didn't put that in. But I really recommend just download the tute. I've already found a couple of typos in it, and I've written the answers too. I just haven't named them correctly, so it hasn't gone up yet, but I'll put it up after this. So have a go at the tute, and it will help. So next, when we actually look at this graph, we don't find anything all that exciting. It's just a whole lot of lines going everywhere. So let's, so basically what I wanted to do was say, so if we look at 2021 and 2020, well, 2020 particularly, during COVID, do we have a lot better reliability of trains than other years? And what we see is that 2019 wasn't very good. That's kind of the tealy color. But 2020 no, it really wasn't that much better than other years. Apart from, you know, September and October were pretty good. That was probably during the second lockdown. So let's have a look at the other measure and see if we can get something a bit more obvious. So I'll look at the graph first. So if we look at this graph, we see that the blue line for 2020 is a lot higher than the rest of the lines. And the rest of the lines do seem to all be sort of bunching together, you know, around, I don't know, a mean of, I don't know, 92% or something. But you look at, you know, as soon as you get to April, you're in like, you know, over 95% punctuality in trains. And that's probably because nobody was taking them, you know, so the trains weren't waiting for people to get on and off because everybody was at home, apart from essential workers. So yeah, that's what I wanted to show, like how to just have a go at looking at the data at first, and then you might want to look, you know, in more detail at the different lines, or you know, look at it a different way. So here we've got a very similar plot. I've just like laid it out slightly differently. So instead of filtering the data first, I've put that filter within the data equals, and you don't have to have the data equals part of it. I've just put it in the ggplot call. It's a bit, like I said, it's a bit messy because there's so much filtering in there. But you know, if you get your data set to exactly the data set you want to plot and put that in a particular variable name, you can easily just put that variable in there, and that will make it a bit clearer to read. So same as the other one, we've got the factor and the levels for the service month, just so that that displays well. And yeah, it's pretty much exactly the same, only that the only thing I've changed is the filter here. I'm filtering on punctuality. And yeah, so that's, we do actually see something in that data, which is good. And I've even actually typed manually in the data for Metro for February, so you can see that it's still good in 2021. So other ways of looking at this data. So we're still in the sort of like data exploration phase. So if we, so earlier we summarized up into mode level of kind of just everything for the one mode. And but because we've done that, we can show the different modes on one graph. And now in this case, I am using service date, so that I can get a continuous, this time I'm not sort of wrapping it, like before I was kind of wrapping it around, like having a different color for each year. This time I'm just doing a graph like Peter Parker has in his, which he's just taken from the app. But what I've done is I've put the 3 different data sets on the same graph. So you can see, yeah, V-Line and Yarra don't generally tend to be as on time as Metro, but then when you get to 2020, obviously something's happened here, and the Metro trains are there's even one point where Yarra is actually better than V-Line is actually better than Metro there. Wow. And Yarra's a lot better than it was. So no outliers and a clean data is a myth. Nothing can be 100% right in there. Yeah, well, it's not really it's not really an error in the data, but there is some data that's missing in what I've given you, because there's one route which the city circle doesn't have punctuality measure, like it's not reported. So you'll get some errors with like, oh, I'm missing these lines, and it's because the data's not supposed to be there. Yes, that's that they are performing very well during COVID. So this is why we did the cleaning. Now this is probably not the best way of showing it, but this is kind of a precursor plot to the next one. So what we did is so this time I'm filtering only up to 2018 and not 2021. So I've got so 3 different years. And so in this case, I'm using something called facet wrap, and it's just a really quick way of showing the different modes, like just doing 3 plots all at once in one statement. So we'll go through. Now, this is not the most ideal way of looking at it, because you can see that I don't know, looking at this plot, whether the blue line, the top blue line or the bottom blue line is punctuality or reliability. But you know, you could, you know, change the colors. So, you know, there's a dark green for one and a light green for the other. But I just thought I'd quickly show, well, this is how you can put things on, put lines in the one plot. So basically what I've done here is I haven't noticed that I'm not filtering for punctuality or reliability. So they just both show up. And I do the usual thing with getting the nice months happening, and Y is always the value, and I'm coloring by the year, but notice that I'm not differentiating between the two. But I've done that because I know that the lower one is going to be the punctuality, but it's not ideal. You need to do the grouping so that, and in fact, you should take this code, take out one or multiple of these groups. In some cases, I might have left groupings in there that don't need UN. Yep, I'm just about to explain that. Sometimes I might have left in extra groupings that aren't needed, but it's probably better to group too much than not enough in this case. So what it means is, and like I said, I really should have kept these disastrous examples of what happens when you don't do this. Like if you don't tell it, if you don't tell it separate out into these groups, what it does is it takes, it'll have a value for 3 different modes and 2 different measures, and in this case 3 different service years. So you'll have all of those points will all try to go in the same place on the line when there should only be 1 point on that line. So you just get crazy lines doing this. And so that's why you have to group. I was sort of hoping that I would be able to get away without having to explain this. So hopefully the tutors will be able to explain this to you better. But basically, you should try it out. If you don't put the groupings in by what you're showing, you'll know. Yeah. So you're not going to like mess it up by forgetting something. If you look at the line and it's wrong, you'll be able to tell. So I'm still using geom line to draw the line graph. So facet wrap and mode. So that says I'm putting the mode across here. Now this is kind of a little formula kind of thing, which happens in a few places in R. So we'll see a bit more of that later. In the next slide. Okay, so once again, I've used the legend position and changed the labels. And yeah, so that's that one, just as an example of the way you can do it. Why do you need to transform service year to character for color? As I explained before, it's if you don't make it as character, it sees a number. It sees a numeric value, and it says, "Oh, okay. Well, you must want I can't even. My words aren't working. When you have a variable that's continuous, it's going to want to. It sort of automatically gives you a continuous scale of color. And you should just try it. Basically, try it without, and you'll see why you want to put it as a character, because I want to in this graph, the year is a category. It's not a, like, I don't want to see, you know, I don't have like 20 values and I want to have a lighter, you know, one color for 2020, for 2010 and slowly morphing into another color for 2020. I want very different colors, and that's why I've used as character. Okay, so now this is, we're getting close. Facet grid. So this one is for this graph. So it's like the previous graph, but what I've done is I've separated out the punctuality and the reliability, and it's not really that interesting a graph because the performance is so, the reliability is so much higher and more unchanging than the punctuality. But it shows how you can easily take, so when you've got tidy data, you can split out by, you know, I have these because I've got this data sort of cut in different ways. So I've got mode and I've got punctuality or reliability, and I've got year as well. It's a way of just separating out those values. So you'll see in the tute, I show you a bit more, not so much with facet grid, but just how powerful it is to be able to quickly sort of split things out. So you might think of better ways of using this, or you could have something else across the top and put the, you know, you could put the years down, you know, the y-axis, or you just play around. Like sometimes the best way to find stuff in data is just to do crazy plots and see if you can see anything. That's what I did for the tute. I just did some crazy plots and I saw some things that I wanted you to find in the data. So why are there 6 lines in each plot? So in this case, because no, there shouldn't be 3, because not only do we have 3 modes, we also have 2 different performance variables. We have punctuality and reliability. You just can't see it on the, it's not on the left side of the graph, it's on the right side. So I'll now explain the code. I couldn't fit the code and the graph at the same time. So what we've done is we've taken our tidy data, we've filtered the years. Now we've kept all of the modes and we've kept both punctuality both performance variables. So we're still using the X equals factor. We're still using Y for the value. We've still got the same color statement. So we're grouping by these and we're doing a geom line. Oh, and also notice that you will have to keep, if you're splitting the line, you've got to keep the plus on the same line, otherwise it will think you're finished with that line. So that's something to avoid. So we've got a geom line, and so, but then instead of doing a facet wrap, we're doing a facet grid. And so the reason I've put Y to X up in the top is to remind you which is which. So when we do facet grid, instead of, so for the facet wrap, it just puts them like that, or it'll wrap them around if there's more than will fit. But here, it will give you the measure by the mode. And you can see that here. So we've got the Y was the Y was the measure, and that was the value, which is punctuality or reliability. And the mode is across the X axis. So that's why I've called that X. And yes, there are 5 different years in each. So the year is going across the color, and there's a separate line for each color. And yes, the mode and measure are separated down the side. Yeah. And notice that it's a tilde or whatever they're called. It's not actually a dash. And that's the way some things work in R. So, and I've just got the same usual things at the bottom for the legend and the labels. And yeah, so I just wanted to show what you can do with Facet Grid, and just give it a go and see if you can do something useful for it. You'll find in the tute I use the facet wrap a little bit. Okay, so I hope I haven't. Now, Karan is asking, group in ggplot, is it similar to group by? Kind of, yeah. It's kind of like a, it's like a, yeah. You're sort of telling which are the sort of, which are the things that define the piece of data that you want to look at, which uniquely identify them, I think. Yeah. Okay, so any other questions? Oh, Janice has asked, can we use a group by instead of a group equals paste? No, I don't think so. It's the same sort of idea, but it's a different grouping. Yeah. But yeah, like I said, if you try making some plots, you'll know when you get it wrong. Yeah. Okay. So are we having another session with me with more real examples? No, I am just doing one lecture, but I've written the tute and I was just finishing it today, and I have given you, so it's the same data, I've given you all of the code that I've used to clean the data, and I get you to group it in a different way. And then you look at, because we have so many different lines, what I do is I get you to group it up. So you see how all the lines that are the same color, so all the pink ones are St Kilda Road, I think. So we summarize the data up into, you know, just a few different ones for each mode, and then you can sort of, because you can't look at a graph like that, you know, and get a lot of meaning from it because it's so messy. So what I do in the tute is, yeah, we look at just a few lines for each mode, and then you can say, well, does this group of lines usually perform badly, and how, you know, compare the 2020 performance to previous performance. So Janice would like me to explain the difference between group equals paste and group itself. Okay, so when we have oh, okay, I see what you mean. Do you mean, why have I used a paste instead of just a group in this code? I think I'm just trying to find a good example which has lots of, yeah. So I think, yeah, Janice is asking about this, which I didn't realize that that's what she meant. Okay, the reason that I've used paste is, I think how it works, and I'm not an expert on this, is, so basically I think what this does is it gives it kind of a unique identifier. So it goes through the data and it says, okay, I've got these lines which I have multiple values. You know, I've got multiple values, and what I need to do is I need to group, I need to split out the values so that I get a different line for each. I sort of look at the data by from a particular kind of lens. Yes, I think so. I think it's Karan. I think it's because oh, okay. Sorry. Yeah, I think it's because you need a Karan suggests that you can't use C parentheses, you're using paste because then that just gives you one text value that identifies this is what I need to graph by. And Janie is asking page 30. Oh, okay. All the slides are online, but yep, sure. Oh, yeah, sorry, I couldn't fit it because it's so long, and if you break that line, the file won't read. So yeah, sure. I will just paste that. Sorry about that. I did mean to put that up on the website, but I haven't had a chance yet so that you guys could see it. No worries. Yeah, so, and you also, what you should do is before the tute, actually have a look at the data, even if it's just in Excel, just to get an idea of what the format is. Because when you look, I mean, you can't really see in the, where I paste in little bits of, you can't sort of really get an idea of what the data looks like if you're just looking at that tiny bit. So yeah, have a look in Excel. So. So are there any other questions that I've missed?
I got a small question.
Yeah, sure.
May I ask you a question regarding to the quiz, the online quiz, because
yes.
there is
I'm sorry, it's hard. I know.
No,
yep.
But there is unclear stuff.
Yep.
How many different trim routines are there in the data show in the lecture?
Yeah.
Actually, there should be 26, right?
Yeah.
Because there are 3 more. I don't know
yeah,
which one this question is pointing to.
Yeah, I mentioned, I'm just trying to find the right slide. I mentioned tram, so it's in.
It's at 30, I think.
So it's there, and it's also here.
Yeah, so it should be 26,
yes.
right?
Yeah.
So, okay.
Yep.
So the maximum number. I just want to ensure.
Yeah, it's probably also because also you might not know that Yarra means tram. I should have clarified that because that's
there are different operators, right?
Yes. So yes, Yarra means tram, and it's sort of. Yeah, I didn't mean that to be that hard.
Okay.
But
it's okay.
Yeah, so that's no. What I mean is I don't mean no. I meant I didn't realize that I hadn't made that clear because I know it. Like So yeah, no, I don't have that. So yes, tram means Yarra. Yeah.
Okay.
Yeah.
Got
it's
it.
just
Thank
it's just here. This is what I was looking for. Yarra trams. Yeah.
Okay.
It's just a artifact of the database that the data's come from calls it Yarra, or my colleague who's given me the data has called that tab Yarra. So yeah, sorry, that was.
Got it. Thank you. Thank you.
No worries. Yep.
Bye.
There's some harder questions in the quiz than that, but hopefully I've explained them. Yeah, and yes, the question about the AES equals factor, the month factor. Hopefully, I've explained that well enough that it's not comparing the values. It's tidying them up so that they look nice when you plot them.
Just on that with the month when we turned it into a factor.
Yep.
I asked a question about the color earlier. Can we do that with the year, the service year as well? Like instead of as character, we turn it to a factor?
You could. Yeah, but you don't need to as much. I'm just trying to think of a good explanation for that. So you're saying, can we put a factor around? Yeah, I think that would work. And I think by default, because service year is numerical, it will the levels will be in the correct order. So if you just put factor service year, I think that would work too. Yeah. Yeah. That's a good question. Yeah. Janie is asking, what kind of problems do I deal with in the workplace? Could I name some? Sometimes it's dealing with data that has come from consultants and is not sort of, you know, my biggest problems at work are often dealing with people who don't do things the way I want them to be done. Because, you know, having used R and having studied statistics, sometimes you see people using data in a way that doesn't make sense, and you sort of have to very carefully explain to them why they should do it the way that you think. Like, for example, we had some consultants who worked on, so we were looking at, there's a thing called movement and place, which is a long story, but so we're looking at train stations, so every single train station on the network, and we were sort of looking at little sort of ratings about each one, like do they have lots of passengers, are they in a nice place, do they have lots of connections to other services, all this. And so this is at least 200, if not 300 train stations, and many variables all being calculated with VLOOKUPs off many different sheets from many different places. So this was basically a database in a 50 megabyte spreadsheet. And, you know, it would crash if I tried to open it sometimes. And so I think sometimes the hardest thing about being a data person is making things better and more sort of data sensible, if getting people to do things sensibly, if that makes sense. So yeah.
May I ask you a question?
Yep.
Regarding the workplace as well?
Yep.
So normally you guys deal with a lot of big data, right? For example, 100 gigabytes or
Yeah.
something like that, right?
Yeah.
So how you guys kind of using those data, because it's too big at the start. So how you guys process it in order to do the data analysis?
It's really unfortunate for me because I don't have access to many databases anymore. There are issues in the public service where sometimes you will have areas that don't talk to each other. So patronage have got a database, I don't have access to it. The data, what's called enterprise information management, they have a database that I can only access some things from. And, you know, there's not a lot of people who would know how to query a database in that I work with. So it's very difficult to get access to the things that I need to get access to because I'm in a different area, so I'm not trusted with their data. So there are programs where people are trying to improve the visibility of data across the department, or, you know, trying to get data people talking to each other and, you know, improve situations that we have. But it's you have to. I haven't worked in sort of private enterprise for a few years, but you know, you have to be. You know, don't be surprised if you get frustrated when you start working with things not being done well. You have to learn how to cope with that. So would be my advice. Yeah.
Okay, cool. Thank you.
Yeah, no worries. Okay, anyone else? No other questions? Great. Okay, well, thank you very much for coming. I hope it wasn't too boring or too hard. And yeah, I hope you get to learn a little bit more about about plotting in R and manipulating data. Great. I'm really glad. Thank you for saying that it was interesting.
Belinda, do you want to just stay on the line and,
Yeah.
and maybe I can help you with uploading the video too?
Sure.